All right, so on these graphs, when we're graphing these, every single trig function through the entire chapter, I'm going to ask you to write down these three pieces of information. We need to know our amplitude, our period, and our count by. Now, this problem is a little bit different because there is a negative on the x. Now, if you remember from college algebra, transformations, when there's a negative on the x, it flips it over the y-axis. We could certainly do that here, but we kind of have everything set up to graph between like 0 and 2 pi, so it gives us all the nice information. So what I'm going to do is rewrite this first. Remember yesterday, we talked about the properties of sine and cosine, and we said that sine was an odd function. What did that mean?
Symmetric to the origin.
Right, it was symmetric to the origin. And so back in college algebra, when something was symmetric to the origin, that meant if you put in the negative x, you got out negative y. It was two flips. Cosine is even. If you have a negative on the x, it can just drop off. Sine is odd, so if we have a negative on the angle, we are going to factor it out. And I'm going to rewrite x over 2. I'm just going to put 1/2 x. Those are equivalent, but this may make it a little more obvious as we do our other steps. So because it was sine, and sine is an odd function, which we learned yesterday, the negative comes out in front. Transformation-wise, a negative in front is a little bit easier. What happens if you have a negative out in front? It flips it. So flip over the x-axis, that just means our graph will be upside down. So what I usually do is anytime I see a negative, I just make myself a note right now that I'm going to flip. Amplitude. We talked about yesterday. Amplitude is your high and low points, and that is just the number out in front. It is always positive. So the negative causes me to flip. My amplitude is just 3. That's my height. Period. How long does it normally take sine and cosine until they start repeating? 2 pi, because that's how far it takes to go all the way around the circle. So we learned yesterday to find the period, you do 2 pi divided by the number in front of x. So 2 pi divided by 1/2 is 4 pi. All right, that means when I go from 0 to 4 pi, I will have one complete cycle of my graph. We are trying to break it up so we can put the nice points on our x-axis that would give us like our high and low points. And so to do that, we always do our period and divide it by 4 for the 4 quadrants. And so when we do that, we get pi. All right, now we can draw a graph. So I am starting at 0. My amplitude is 3, so that means my high point would be at positive 3, my low point would be at negative 3. I told you on the x-axis we always have 5 points, our starting point, and then 4 after that. We're starting at 0, I'm counting by pi, so 0 plus pi is pi, plus pi is 2 pi, plus pi is 3 pi, plus pi is 4 pi. All right. Sine. What is the sine of 0? 0. Sine always starts at 0. And then if we think about our pattern from yesterday, it goes up, right? But what did we say was happening on this one? It was going to flip. So instead of going up first, it will go down. So at pi, I would be at my amplitude of negative 3. Then I go back to 0, up to 3, back to 0. Okay, we strategically chose these points on the x-axis so that we could just follow the pattern. But if you got confused, we are just plotting points. You know, you could put in a 0 here. So you get 3 times the sine of 0, which is 0. If you put in a pi, sine of negative pi over 2 is negative 1. Times 3 is negative 3. If I put in a 2 pi, sine of negative pi is 0. Times 3 is 0. So we're just plotting the points that we get. So then we know our graph is a curve, so please make sure you are curving it and it's not a zigzag. And it would look like this. Sometimes, especially as we do more of these, I'm only going to ask for 1 period, but these first few I did ask for 2 periods. How do we get a second period? So we need 4 more points. We already have our starting point, so we just need the 4 after that. And we keep adding our count by, which was pi. So then 5 pi, 6 pi, 7 pi, 8 pi. And we keep following our pattern. So now we're going to go down to negative 3, back to 0, up to positive 3, back to 0. And we can see we have 2 periods. We have 2 complete cycles of the graph. What questions do you guys have? Let's try one more. All right. Information, same thing every time. Amplitude, period, count by. Amplitude is a positive number. What does it mean if there's a negative in front? Okay, so the negative is going to flip it. My amplitude is 3. How do we find period? So 2 pi divided by, the thing in front of x here is just pi. So we just get 2. All right, count by is always whatever we get for our period divided by 4 for the 4 quadrants. And we get 1/2. So amplitude is 3. That means high point would be at positive 3, low point would be at negative 3. Points on the x-axis. I'm starting at 0, and I count by 1/2. So we should have 5 total points. 0 and 4 after that. Add 1/2 each time. So we get 1/2, 1, 3/2, 2. Okay, how does cosine usually start? Usually starts at its amplitude because cosine of 0 is 1. But we're flipping it, so instead of starting at 3, it would be negative 3. If you aren't sure, plug in a 0 here. Negative 3 times the cosine of 0 would be negative 3 times 1, which is negative 3. So we're not just making up points, it's what you get if you plug them in. We're just using the pattern to save ourselves some time there. So then we have to hit 0, high point of 3, back to 0, low point of negative 3. Oops. And that would be 1 period of my graph. So to get a second period, we would just need 4 more points. You just keep adding your count by. So we'd have 5/2, 3, 7 halves, and 4. And just keep alternating the points. What questions do you guys have for me? Is this going okay? Yeah.
How do you get the points? Like, what did you say? It was above like the words.
Oh.
Were you quoting the number?
Yeah, so you can either remember what cosine looks like sine always starts at 0 and goes up. Cosine starts at its high point and comes back down. Or, if you're in doubt, we really just have the points, like if you wanted to make a t-chart, those points we put on the x-axis are the points that we're essentially just plugging in to get our values. So if you put in a 0, -3 times the cosine of 0. So that's -3 times 1, which is -3. If I put in 1/2, that's pi over 2. Cosine of pi over 2 is 0, times -3 is 0. If I put in 1, cosine of pi, which is -1, times -3 is 3. So that's where my y values are coming from. So you can either get them from there or remember your pattern. If you forget the pattern, that's a great way to figure it back out from. What else? I want to look at just a couple of these where I give you a graph and I want you to tell me what the equation is from that graph. All right, so first we have to decide, is this a sine or a cosine graph? Cosine. Sine starts at the middle, right? Sine of 0 is 0 and bounces back and forth. Cosine starts at its high point. So this is a cosine. But cosine normally starts up here and goes down. So what made it start down here? There was a negative in front. Okay. What is the amplitude of this graph? 2, because it goes up to 2 and down to -2. So the amplitude, it goes in front. So it's a -2 cosine. All we have left is to figure out the angle. So let's think about our period. The period is how long it takes until it starts repeating. Okay, so I've got, doesn't repeat. I get all the way to 4 pi. So 4 pi is my period. Think about how we find period. We take 2 pi divided by the number in front of x, and that equals our period. So let's solve for b. Okay, if I multiply that b to both sides, that would cancel. We divide by 4 pi. 2 pi over 4 pi reduces to 1/2. So it's 2 cosine, sorry, -2 cosine of 1/2 x. One more. Is this one sine or cosine? Sine because it starts in the middle. Was it flipped? Nope, so it doesn't have a negative. What is my amplitude? So we have to have a 4. All right, let's talk about period. Period is how long until it starts to repeat. I drew the graph until 2 pi. But if I look, once I get to pi, doesn't it just repeat itself after that? So I graphed 2 periods of it. The actual period, the length until it started to repeat, is just pi. Okay, so think about what that does in our equation. We take 2 pi divided by the number in front of x, and it has to equal our period, which is pi. So if I multiply my b over, divide by pi, so the number in front of x has to be 2. So it's 4 sine of 2x. So what I want to do now, yesterday I told you the homework for this chapter is a little bit different. I just posted one big document that has every section. You're doing it on notebook paper so that you can draw your graphs as big or as small as you need. So your assignment due Monday is section 4.1. So that's 1 through 18. I'm going to give you a little bit of time to work right now. In about 15 or 20 minutes, I'm going to come back and do a little bit out of the next section. Okay, I'm not going to give any more homework today, but I'm going to start that next section and then we'll finish it Monday. So with our trig functions, we have talked about some of the common features. But if you think back to transformations, our only transformations weren't stretching and shrinking, were they? We've talked about like the amplitude, which is like a vertical stretch. We've talked about the period, which is a horizontal stretch and shrink. And we've talked about flipping. But what other transformations did we have? We could move graphs up and down and left and right. Now, in terms of moving it left and right, it's not like it truly starts and stops here because we know these are waves. They keep going. But our points get shifted over. Okay, our goal is still to make this as easy as possible. So we are trying to follow our pattern. We don't want to get stuck making a t-chart and plugging in 15 points every time we draw a graph. We want to use the fact that we know sine starts at 0 and goes up, cosine starts at its high point and goes down. We want to use that. So a couple phrases that you will hear in the section, and we're going to talk about a phase shift and the argument. So a phase shift is just another word for the horizontal move. How far left or right does our graph move? The argument is where we are evaluating the trig function. So it's whatever we are doing sine or cosine of. So for these problems, what I am going to do, the phase shift is kind of tricky. You know, we have all these points on our x-axis, like 0, pi over 2, pi, 3 pi over 2, 2 pi. And if I start saying, okay, now move each of those points left pi over 4, you're doing a lot of calculations to move every single one of those points to the left. And our graph, if we're trying to graph the parent function and then shift it over, it's going to get really ugly, especially when we get out of sine and cosine because the other ones have places where they're undefined, which means they have asymptotes on our graph, and that just gets super ugly. So what I am going to do instead is set up an interval on all these problems. So the period is how long it takes to repeat. The interval is basically a nice section of the graph where we would get one full period. Where should I start and stop this graph if I want to get one full period? So what I want to do is maybe do one of these, and that might be as far as I get for today. We'll see. So our setup, same as previously. We are still going to do the amplitude, the period, and the count by. What is my amplitude? 1. There's nothing in front, so it's just 1. Period is 2 pi divided by the number in front of x. What's x being multiplied with? Just a 1, right? There's nothing else with it. So my period is just 2 pi. My count by, what do we do? So we get pi over 2. Now, if I just start at 0 and end at 2 pi, using my multiples of pi over 2, well, I will certainly get points in my graph, but they're not necessarily the high and low points that we want. So the next piece I'm going to do is an interval. And I have to do this because I have something added or subtracted in my angle. So when we set up an interval, what we're going to do is say, well, sine normally starts at 0 and ends at 2 pi. And I'm going to put my argument in here, the thing we are evaluating. So inside my parentheses. Now I want to solve this for x. So if you're trying to get x by itself, what would you do? Okay, so if I subtract that from everything, I get negative 3 pi over 4 is less than or equal to x is less than or equal to 2 is like 8 over 4 minus 3 over 4 would be 5 over 4. All right. This isn't the only place this graph exists. But if we think about our transformations, that plus pi over 4 would move my graph to the left pi over 4. And so I basically found out if I move it left pi over 4, my first point should be here and my last point should be here. So now, let's do our graph. And this time, I only asked for one period. Okay, now, I do have, my first point is at negative pi over 4, right? So we do have to be a little bit more careful, especially with our spacing on these. If you mess up, you can always readjust your points. We need them to be equally spaced. My first point is at negative 3 pi over 4, negative 3/4. What am I adding to get my next point? Pi over 2. So it's like adding 1/2. You can use a calculator, negative 3 over 4 plus 1/2, or you could do negative 3 over 2 plus, or negative 3 over 4 plus 2 over 4 would be negative pi over 4. Okay, if I add pi over 2 again, I get positive pi over 4. So this is where you might have to kind of fix these so that everything is spaced. There should be the same distance between the negative 3 pi over 4 and the negative pi over 4 as there is between these two. How many total points on my x-axis do we need? We always do our starting and 4 after that, right? So if I keep going, add pi over 2, that would be 3 pi over 2. Sorry, 3 pi over 4. I need one more point, and that would be 5 pi over 4. Where have you seen 5 pi over 4 before? Isn't that where we said our interval should end? That's a good check to see if you made a mistake. Your fifth point should be where the interval was supposed to end.
Why did we not use 0 on this?
Because when we added the multiples of 1/2, we didn't hit it. All right, my amplitude is 1, so high point 1, low point negative 1. Okay, sine. How does the graph of sine begin? At its 0 point. So my first point, the negative 3 pi over 4, that's when we're at 0. And then sine goes up. So my next x-axis point, I go up to 1. At pi over 4, I'm back to 0. 3 pi over 4 is negative 1. 5 pi over 4, I'm back to 0. And that is my graph. So if we have something added or subtracted with our x, we have to do this interval to figure out where to start and stop. Any questions there? That's about all I have time for today. So we will pick up with these Monday, but the first handout is due